Let's begin. Today is September 23rd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 6, 11, 16, 19, 21, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A looks at our middle digit, the square digit, and will let us know whether that value is an even digit or an odd digit. Criteria card B looks at our first 2 digits, triangle and square, and compares them. So should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card C will look at our 3-digit solution and will let us know a little bit about the ratio of even to odds. So are there more even than odds, or are there less even than odds? Criteria card D again looks at our first 2 digits, triangle and square, but this time it'll add them together and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E again looks at our 3-digit solution, but this time will let us know a little bit about its structure, so to speak. Specifically, it'll let us know if there's a pair, as in the example 131, or it could be that there is no pair, and there are a couple of distinctions. One where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F again looks at our 3-digit solution from triangle to square to circle, and will let us know a little bit about the ordering of the digits. So should the digits appear in an ascending order, meaning that they're increasing, as in the example 135, are they in a descending order, signifying that they are decreasing, as in the example 421, or could it be that it has no order? So let's take a look at the example of 231. Notice that it goes from 2 to 3 and then 3 to 1. That shift from increasing to decreasing is one way to define a 3-digit code to have no order. We've also seen other puzzles where consecutive equal digits, meaning digits that are next to each other, are equal. Those also exhibit no order because there is no change between those digits. So that again is another way to define no order. Now remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to test is I want to know a little bit about that middle digit. So let's go ahead and test criteria card A. Okay, so the Turing Machine does not approve of my choice for square. I did choose an odd 1. The fact that it does not agree with it lets us know that actually square is an even digit. So let's go ahead and type that up in our notes in section A, and that is that square is an even digit. And since it is even, we can go ahead and cross out all of the odds in square. So crossing out 1, 3, and finally 5. So I apologize, experiencing a little bit of a lag. Okay, so now that we've established that square is even, let's go ahead and test criteria card C. Okay, so in this case, the Turing Machine does approve of my proposal. Remember, for criteria card C, we're looking at evens versus odds. And if you notice in 314, I do have two odds to a single even, and that's what it approves of. It has less even than odds. So let's go ahead and type that up in our notes in section C, and that is that there are less even than odds. And so what we can take away from criteria card C and A is that since, again, we have established that square is even, that means that both triangle and circle must be odd. So let's go ahead and cross out all of the evens in both triangle and square. Okay, so what can we test next? Let's go ahead and test criteria card E. Okay, so in criteria card E, we're looking at pairs or no pairs. So if you notice in my proposal of 3, 1, 4, I in fact don't have any pairs. So yeah, and let's type that up in section E. And we'll say that the solution has no pairs. Now again, we do have the two possibilities of either having no digits being the same or a single digit repeated 3 times. Well, it can't be a single digit repeated 3 times because that in fact has no order. There's no change among all 3 digits. And so therefore it would make criteria card F irrelevant. So yeah, we can discount the possibility of it being a single digit repeated 3 times. Okay, so we are looking at an all distinct solution that is odd, even, odd. And again, we have completed the 3 Turing tests for this round. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card B, comparing our first 2 digits. Well, now we know it's an odd versus an even. And we also did not test criteria card D, again looking at our first 2 digits and adding them up together and comparing it to 6. And of course we discussed a little bit about the ordering criteria card F. So what we do know is that since we are dealing with an odd, an even, and square, we know that sum cannot be an even quantity because when you add an odd and an even, it's always odd. So we know it cannot equal to 6. So it's either going to be less than 6 or greater than 6. And so let's see what typically could happen. I think we have an equal amount of less than 6 and greater than 6. We got 1, 2, 1, 4, and 3, 2. 3 possibilities, all adding up to a less than 6. And then of course you've got 5, 2, 5, 4, and 3, 4, all being possibilities greater than 6. So it really does feel like it's going to be a 50-50. And I guess the other possibility is, could it be going to criteria card F, could it be descending, ascending? There are a couple of each, right? 1, 2, 3, 3, 4, 5, 3, 2, 1, 5, 4, 3, all ascending, descending. I don't know. It's possible, and then there's a wide variety of no orders. So are there any possibilities? Notice also that there's no mention of circle at all among our 6 criteria cards. So somehow, obviously, we do know it's going to be an odd, and perhaps the ordering is going to have some way to dictate and force circle to be a particular value. So, yeah, I'm not sure. So if there's like something like no order, could it be something like 3, 2, 5, remembering that there can't be any duplicates? Could be something like that. Let's go ahead and try that. Let's do 3, 2, 5. Okay, so let's go ahead and test. Let's see. Let's go ahead and test criteria card D. Okay, so it is true that the sum of the first two digits is less than 6. So let's go ahead and type that up in our notes for section D. And again, that's where triangle plus square is less than 6. And since the sum is less than 6, can we cross out anything? Well, it looks like I think we can cross out 5 in triangle, because if you were to add 5 to either 2 or 4, those would all give us a sum greater than 6. So I think it's fair to cross that out, but I don't think we can cross out much else, since 4 plus 1 is less than 6, and 3 plus 2 is less than 6. So that's about it. And let's see, let's go ahead and test criteria card B. Okay, so in this case it is not correct. So let's see, we are dealing with triangle and square. So we know it can't be equal, since we are dealing with evens and odds. And I did get it wrong. So in this case, in my proposal, I have triangle being greater than square. That is incorrect. The Turing machine does not approve of that. So that means, in fact, triangle needs to be smaller than square. So let's go ahead and type that up in our notes for section B. And that again is that triangle should be less than square. Okay, so let's take a look. So I think we can actually cross out 4. Oh, sorry. Oh, well, I don't know if we can cross out anything. Let's see, yeah. Triangle needs to be less than square. And yeah, so technically, oh, that's interesting. So we cannot cross out. All we can say is it can't be 3, 2, and that's what I have in my proposal. That's why B is incorrect. But, you know, it could be 3, 4. Yeah, I'm just not sure at this point. Again, somehow these values are going to be forced into something, and I'm wondering it may be, oh, let's see. I'm recalling another puzzle where I believe, let's see, how did it work? I think if we said, hey, if we say that you have an ascending solution, well, of course, if it's ascending, you know that triangle is going to be smaller than square, making this card irrelevant. So we know it's not ascending. Similarly, if you knew the solution was descending, well, of course, triangle would be greater than square, therefore forcing you to pick something like, say, 3, 2, 1, but again, making this card irrelevant. So I think it's safe to deduce that the solution should have no order. Okay, so then we should have enough to pick. So let's see. Square needs to be bigger than triangle. So I don't think, let's see, we may need to start listing out some possible solutions. And so I'm just going to do it in section B here. So let's see. Could triangle be 1? If there's to be no order, let's see, it would be 1, 2. Well, it can't be 1, 2 because 1, 2, 1 wouldn't work because they're supposed to be unique, and there's no way, and of course 1, 2, 3, or 5 would be an ascending solution. So neither of those work out. So it cannot be 1. Oh, well, I apologize. It can't be 1, 2. Yeah, it can't be 1, 2. Okay, so let's go to 1, 4. So if it's 1, 4, I guess it could be 1, 4, 3. That's a possibility. It can't be 1, 4, 1 again because of the duplicates. And it can't be 1, 4, 5 because that's ascending. And it can't be 3, 2 because triangle would be larger than square, and that's not allowed. So that means it would be 3, 4, 1. So 3, 4, 1. Okay. Oh, and of course it can't be 3, 4, 1 because 3 plus 4 is actually the first two digits add up to be something larger than 6. So this is not valid. Wow, very interesting. Okay. So yeah, it looks like the solution should be 1, 4, 3. So there's just quite a bit of things to cross out, so I'll just leave it as such. And let's just review before we go confirm. So is the middle digit even? It is. Is it bigger than the first digit? It is. Are there more odds? There are, 1 and 3. Are the sum of the first two less than 6? Yeah, the sum is 5. And there are no pairs. And again, based on our deduction, it should have no order. And 1, 4, 3 has no order. Well, that looks great. So let's actually go confirm that 1, 4, 3 is our solution. Okay, fantastic, it worked out. So let's actually see, how do we do versus a Turing machine? Well, I believe we did do only 5 tests versus 6 criteria cards, so that's always great. In the first round we did do ACE, and in the second round we did BD and deduced F. So let's go ahead and type that up. So A was incorrect, both C and E were correct. B was incorrect, but D was correct, and we skipped F. Okay, so yeah, we did beat it by that one question. Basically, our deduction of from criteria card F having no order with the assist from criteria card B. So whenever you see criteria card B and criteria card F, again, you can use that same logical argument of assuming there's a ascending order, and again, making criteria card B irrelevant, likewise with assuming it's descending, and likewise making criteria card B irrelevant, forcing you, or reducing to the last option of having no order. Well, what do you think? How did you solve? Did you find any other additional sort of criteria cards in a particular order that helped out in your solving? Or did you notice something about how I did it that you'd like to share? Add those thoughts to the comments. If you liked the video, please give it a thumbs up so that more people can find this channel. And of course, hit subscribe so that you won't miss out on any future videos. Well, until next time, have a great one.